Algebra students, Algebra 1, Algebra 1B. We're going to talk today about rate of change. This is 5.1 notes. It covers the learning standards of linear functions, one part B, and linear functions, one part D. Yeah, if you want to look those up, you guys can actually realize why I'm teaching this to you. More or less, this is for my purpose. But I think it's good that you guys actually realize that I have to teach this to you by Missouri state laws. So if I'm looking at this, our objective is to find the rate of change, and it's also to find slope. A rate of change is a fancy way of saying slope. If you can find the rate of change of something, you're finding the slope. It's just another way of saying slope, okay? Vocabulary rate of change shows the relationship between two changing quantities. Remember that the word quantities means anything that can be counted or measured. So when we're talking about the rate of change of something, we're talking about something that I can actually see growth in or see decay in. Temperature rises and declines, right? I can measure the temperature. So that is the quantity. I can see the rate of change that the temperature does in the morning to the afternoon. Same thing. I can see the decline in bank accounts. I mean, if you guys spend money and stuff like that, you can actually see the rate of change on that. You can see how much money you spend over the time period. So that would be like a decline. Or if something is falling from the sky, whether it be a plane, we can see the rate of change of that, or even its incline. So those are all examples of rate of change. Even with your guys' driving miles per hour, you can see the rate of change that you do as well, from going from I don't know, even the high school to Square Deals for an ice cream. You can see the rate of change that it takes you, the time it takes you to get there, miles per hour. Okay. Rate of change is change in the dependent variable over the change in the independent variable. Over here I have delta. Delta means rate of change. Delta is a Greek letter that means rate of change. So this is just saying change in y over change in x. You'll see this quite a bit in science books. You'll also see it quite a bit in tougher math classes like Algebra 2 and all that. But really, it's just shorthand. It's the shorthand of saying change in the dependent variable over the change in the independent variable. Remember that dependent variable is the y value, and the independent variable is the x value. Slope. Slope is a biggie, okay, because isn't rate of change slope? If we can find slope, then we can find the rate of change. So we have slope equals the vertical change over the horizontal change. Again, it is rise over run. It is y over x. Okay, it's the change in the y over the change in the x. Slope, again, is y over x. This is so important. Like, honestly, if you can get this lesson down, you've made it through chapter 5 for the most part, okay? Because we do so much with slope. We do so much with rate of change in the upcoming lessons that you have got to get this part down, all right? Slope formula that we use is y2 minus y1 over x2 minus x1, and we call that m. M means slope. So if I see the variable m, I know I'm talking about slope. All right, so that is the vocabulary part of this. Let's go ahead and dive into our first problem. So our first problem, we're going to find the rate of change using a table. Remember, rate of change is the change in the dependent variable over the change in the independent variable. It is going to be delta over y over delta over x. All that means is the change. Okay, so we have a number of balloons, and total cost of balloons. Now, I have labeled this as X and Y because I've already predetermined, okay, well, what do I have control over? I answered the question down here. What do I have control over? Well, I have control over the number of balloons. And if I have control of the number of balloons, that's my independent variable. That's going to be X. Cost depends upon the number of balloons, therefore cost is the dependent variable. Okay, so that is why I put a Y up here, because cost depends upon the number of balloons I buy. Therefore, cost is Y. And change means subtract. If I'm trying to find the change in something, I am subtracting it. If I'm trying to find how many miles how much the temperature rose, I'm going to take the temperature that we started out at to the temperature that we are at now and subtract it, and then I can find the change. Correct? Right. So change really means subtract. So how can we go about this? Well, you guys know that it's dependent over independent, and we just said that the dependent variable was the Y and the independent variable was the X, and the Y was the total cost and the X was the number of balloons. That is so important to remember, and it's so important to realize what is my independent variable, what is my dependent variable. If you can get that and write that on your charts, that is going to be the first thing that you ever do when you come to solving these problems. Okay? So I've written down here that, hey, look, this is going to be cost over the number of balloons. Now, down here, I have 6 minus 12 and 2 minus 4, which equals negative 6 over negative 2, and negative 6 divided by negative 2 is 3. Well, where did this come from? Where did these all come from? 12 minus 18, 4 minus 6, and that again gave me the exact same thing. If you notice over here too, 18 minus 24, 6 minus 8 gave me the exact same thing. And if you look over here too, 12 minus 24 over 4 minus 8 gave me the exact same thing, except this was negative 12 over negative 4. But isn't negative 12 over negative 4 3? Yeah, it is. Okay, so where did these numbers come from? How did I get these numbers? Well, I got them from the chart. I went backwards. I said 12. If I went from 12 to 6, that was negative $6, right? Okay. Well, 4 from 2 is negative 2. And that gave me the 6 minus 12, 2 minus 4 over negative 6, negative 2. And that gave me 3. What you could have also done realize too is, hey, how did I get from 6 to 12? Well, I added 6. How did I get from 2 to 4? Well, I added 2. So I could write this out as 6 over 2, which equals 3 because I reduced it. Same thing. How did I get from 12 to 18? I added 6. How did I get from 4 to 6? I added 2. So this change of rate between these two order pairs was again 3. Same thing here, 18 to 24, 6 to 8. It was 3. Well, what about this 12 to 24 stuff? Could I go from 12 to 24 and 4 to 6? Or sorry, 4 to 8? Yeah. 12 to 24 is plus 12, isn't it? Okay, what's the difference between 4 to 8? It's 4. So I could write it out as 12 over 4, which equals 3. So does it matter which order pairs I pick in order to come up with our slope or our rate of change? No, it does not. If it is consistent. If this is a linear function, meaning it is a straight line, then it does not matter what order pairs I have. I'm always going to come up with the exact same thing. Okay, so you guys try out this one. Oops, hang on. Nope, let's do this one. So we got the number of raffle tickets. That's right. We got number of raffle tickets. And then we also have the total cost of raffle tickets. So my thing is 2 raffle tickets cost $1. 4 raffle tickets cost $2. 8 raffle tickets cost $4. 10 raffle tickets cost $5. And we're again asked to find the rate of change. And again, the rate of change means the change in the dependent over the change in the independent. Or in other words, delta y over delta x. Because it's the change in the y over the change in the x. Okay? So the questions I ask myself, first of all, is what do I have control over? What do I have control over? I have control over the number of raffle tickets that I buy. So isn't that the independent variable? Or in other words, the x values? Yeah. So number of raffle tickets is going to be x. So what depends on the number of raffle tickets? The cost does. So therefore the cost is the dependent variable. And what value is the dependent variable? Good, it's the y value. It's the y value. So we know that cost is going to be over the number of raffle tickets because the rate of change is dependent, which is the raffle tickets, over the independent, the cost of the raffle tickets, over the independent, which is the number of raffle tickets. Yes? Awesome. So again, going from here, I took 1 to 2, and 2 to 4. That gave me negative 1 over negative 2. Wow, excuse me. Negative 1 over negative 2, it's going to give me 1/2. So this tells me that for every dollar I spend, I'm going to buy 2 tickets. All right. So, and again, here I took 2 to 4 and 4 to 8. And then, again, I came up with the exact same thing. Negative 2 over negative 4, and that gave me 1/2. It does not matter which 2 order pairs you choose. I could choose these guys, which is what I did down here. But I went from 2 to 1 and 4 to 2. You could go from 1 to 2. So what was the increase between 1 to 2? Good. It was plus 1. What was the increase between 2 and 4? Good. It was plus 2. And again, rate of change is y over x. So it's going to be 1 over 2. Okay, also, if I would have chosen these 2 guys, well, what's the rate of change between 2 and 4? Plus 2. What's the rate of change between 4 and 8? Plus 4. And again, since rate of change is y over x, it's going to be 2 over 4, which equals 1/2. Would it matter if I would have gone to these guys? No, it would not. If I would have chosen these 2 order pairs, I would have said, how did I get from 4 to 5? I went to up 1. Whoops, up 1. How did I get from 8 to 10? I went up 2. And isn't rate of change y over x? Yeah, so it's 1 over 2. Would it have mattered if I would have picked this one and this one? Would it have mattered if I would have picked 2, 1 and 10, 5? No, it would not. It would not matter at all. The only difference is, how did I get from 1 to 5? How did I get from 1 to 5? I added what? I added 4. Good. How did I get from 2 to 10? What did you add? You added 8. And again, isn't rate of change y over x? Yeah, so we have 4 over 8, which again is 1/2. Notice that all these are the same. It does not matter. So what I want you to do is I want you to work out this problem. I want you to work out this problem, and I want you to tell me what the answer is. So go ahead and pause the video and work out this one, the number of lawns and the total earned money. Okay, assuming you did that, you would have realized that the dependent variable was the earned, The independent variable was the number of lawns, because I have control over how much lawns I buy, or how much lawns I mow, not how much lawns I buy, how much lawns I mow. And the money I receive depends upon that. The money I receive depends upon the number of lawns I mowed. So again, rate of change is dependent over independent. And so it's going to be number, or total earned over number of lawns. And I just used the first two, and I came up with $10 for one lawn. If you did not come up with $10 for one lawn, then I would like you to come see me and we can discuss that. Okay? Or go back to your notes and look at that one as well. Okay, so again, I want you to look at this one. Look at this case. There is no independent and dependent variable. I mean, they literally give you X and Y. So go ahead and pause this one and try working this one out. Okay, assuming you paused it, you would have realized that rate of change was Y over X. So it's simply going from 8 to 0. And what was the change in that? Nothing. You had 8, right? Negative 2 to 0. What was the change in that? Negative 2. And you would have came up with negative 4. Again, if you would have chosen different ones, you would have still came up with the exact same thing as negative 4. So that concludes our first part of 5.1.